Are you worried that soon enough you will have no land left for farms? That most farmers are leaving farming for more lucrative career options? That food scarcity would be a global problem? Worry no more. We present to you our innovative solution to all your problems. Here is a fully automated, environment-friendly, low-cost product for multi-level farming. Farming was never so easy. With our completely futuristic automated farming transportation system, you can be assured to have freshness delivered to your doorsteps day after day.
George Washington once said that, "I know of no pursuit in which more real and important services can be rendered to any country than by improving its agriculture." With this in our minds, we set out to provide an innovative farming solution for our future generation. We started with an objective to transport farm products from the farm to a storage place on the same level. We identified the basic functional requirements to be met to achieve our objective. Damage to farm products is a major problem in the current truck-based transportation system. Thus, avoiding damage while plucking, storage, and transportation had to be our primary requirement. Following the current negative trends in farming population, automation is the only answer to meet the current demands of food products. Thus, complete automation was our next requirement. Emissions from transport vehicles are a major contribution to global warming. Thus, it has to be ensured that the vehicle is emission-free and thus environment-friendly. While designing the system for 1000 cross 1000 square meter, we had to make sure that the final output should have the same or lesser price in the market than the one grown in its conventional farms. After several discussions, we had come up with 5 feasible designs for the transportation system. This design has a wall dividing the vertical space above the base in 2 halves. Both the halves have 4 baskets and a robotic arm on each side. Every 8 cross 8 square meter farm has a robotic arm which fills up a corresponding basket for that farm. The vehicle collects filled up baskets and replaces it with an empty one. In this next design, we have baskets attached to a central rotating system. The radius of rotation is more than the width of the base, and hence empty baskets from the vehicle can be replaced by filled up baskets from the farm during rotation. This concept has perpendicular movable rails on the ceiling which cover the entire area of the ceiling. The box for fruit collection is attached to these rails vertically, and every box has an arm attached to it. The arm collects fruits and then puts them in the boxes which travel on the ceiling itself to the storage room. The fourth design has 2 walls on the boundary with 4 baskets attached to each wall. As you can see, there is a robotic arm in the center which can replace the filled up baskets of the farm by the empty baskets on the vehicle. In this design, each basket is attached to an expanding scissor which makes the replacement of the filled up baskets by the empty baskets pretty simple. After carrying out AHP for 8 criterion as shown, we found out that the fourth design using one robotic arm was the best design. This design stood out particularly in low cost, easy maintenance, and minimal damage to product criterion. The 5 degree of freedom robotic arm removes filled up baskets from the field and replaces it with an empty basket from the vehicle. It can work at approximately 30 baskets per hour per vehicle. For design of basket, we started with a cubical basket with solid walls. For providing suspension to a falling fruit, we used netted walls. To ease cleaning, the basket was made cylindrical in shape so that it could rotate about its axis while jets of water would act upon it from different directions for effective cleaning. The blue area at the center is a processing center where products will be cleaned and stored. Length of the vehicle is 2 meter, basket diameter is 0.3 meter, and height is 0.5 meter. Keeping in mind the 4 R's of the design for environment, our design provides reduced carbon emissions, reuse of cleaning water, recycling of organic waste, and easy repairing of all parts. Considering design for service, our vehicle has 4 modules: the circuit box, robotic arm, product basket, and battery. This ensures easy servicing of every part in reduced time. For DFM, we changed design of wall of the vehicle. Instead of welding the joints at 8 different points, the adaptation in design allows it to be manufactured by stamping or plastic injection molding, which is easier to manufacture. After performing FMEA on the design, we found sensor failure as the most critical failure mode. For its correction, we have mechanical shock sensors on the vehicle which won't fail in most scenarios. The most important cost in our design is of the robotic arm, which is around rupees 4.5 lakh. The total cost of one transport vehicle is around rupees 5.22 lakhs. With a lifetime of around 15 years and 7 years warranty, robotic arm is a sound, reliable product to be used. We used Google Docs, SolidWorks, Windows Movie Maker, and Microsoft PowerPoint for the project. Let us now introduce you to the team behind this project. Hitesh Lalwani as team leader, Shri Krishna Kotkar as achiever, Vikalp Jambulkar as CAD specialist, and Ajitesh Rakshas as the challenger. Inspired by the great words of Sir George Washington, we hope our design will be of great service to Mother Earth. Thank you.